Hello everybody, so today I will use about the calculus. The topic today is about apply the first derivative to find the maximum volume. So the question is, an open top box is to be made from a 24 inches by 36 inches piece of cardboard by removing a square from each corner of the box and folding up the flaps on each side. What size square should be cut out of each corner to get a box with a maximum volume? So we can see that we have 24 and 36. That's about the rectangle. We have 36 and 24. The question is that removing a square from each corner of the box. So we have the square, we have the rectangle and we put the square in here. Later that they will folding up to make the box in each side. So the question they ask, what is the maximum volume? So first we put the S in here. S is the side we need to cut in the square. So that because we folding up, so the S in here, there should be the height of the box. And because we folding in here, so that the base, they should be in here. Let's see about the base of the box. So the length and the width of the base, they should be 36 minus 2s. Why we need to put the 2s? Because in the length in here, we need to minus 1s and another 1s in here. That's why we need to minus 2s. Similar with the width. We have 24, but we need to minus 1s and another s in here. That's why this one is about 24 minus 2s. So that's the first step. The second one, that's about the volume. So the volume is about the length multiplied with the width multiplied with the height. And we have length is about 36 minus 2s, 24 minus 2s, and height is about the s in here. So that's the second step. To find the maximum volume, we will do first derivative of volume. So we will do first derivative of this function. So because we have three things, A, B, and C. If we do first derivative of A, B, and C, we will do like this. We will do A first, then B later, and the final, that's about C. Let's see the technique how to do first derivative of this like this. So we do A first. A is about 36 minus 2s. First derivative of the minus 2s is about minus 2 multiplied 4s. We have first derivative. Let's see about number 2 again, but right now we keep the A. First derivative of C is about this thing. Now we multiply together. We have minus 2 multiplied 24 is about minus 48. Minus 2 with minus 2 is about 4. Minus 2, and we have the s in here. So we put our s in here, and we have s power 2. Similar this one, we have minus 2 with the 36 is about minus 72. Minus 2 with the minus 2s is about plus 4s. We have s in here, so we have s power 2 and s in here. The next one, 36 multiplied with 24, you got about 864. 36 multiplied with minus 2s, you got about minus 72s in here. Minus 2s multiplied with 24, you got about minus 48s. Minus 2 multiplied with minus 2, you got 4s power 2. And now we will sum everything together. 4, 4, and 4, you got about 12s power 2 minus 48 minus 72 minus 42. You got about minus 240s in here, and you got about 864. Now we put first derivative equal to 0, so this one will become to 0 in here, and you find two solution. You got about 10 plus 2 square root of 7 and 10 minus 2 square root of 7. This one approximately about 15.29. This one is about 4.708. Now we will put two numbers to compare which one is the highest volume. So if we have the function in here, this one, this one they got about minus 445. And this one is about 1825.29. So we will choose this one because they provide a negative number, and we need to get about positive number. That's why we choose this number as the final answer. This is the end. Thank you for watching.